When you use System.loadLibrary in Java to load a JNI library, you're really asking the operating system's dynamic linker to do the heavy lifting. The JVM only locates the first .so file, but after that, the dynamic linker takes over. Here's what happens internally. First, the JVM finds your JNI library, for example libfoo.so. The dynamic loader then inspects its ELF headers, looking for dependencies in the dt_needed section. If libfoo.so depends on another library like libbar.so, the loader now has to resolve and load that as well. Where does it look? It uses a search order. At the top is ld_library_path, an environment variable you can set to point to custom directories. Next come any rpath or RUNPATH entries that were baked into the .so file at link time, often with the $origin trick to reference the library's own directory. If neither of those work, it falls back to system directories like lib or /usr/lib. Once the loader finds each dependency, it links symbols, applies relocations, and runs static initializers. If any dependency is missing, your JNI call fails with UnsatisfiedLinkError, saying it can't open a required shared object file. It's important to realize that Djava.library.path only tells the JVM where to find the very first library you load. It has no effect on how the operating system resolves dependencies. That's why you sometimes see code work on one machine and fail on another. The dependencies weren't in the right place. To debug this, you can use LDD to see what dependencies a library needs. readelf d to inspect its dynamic section, and ld_debug equals libs to trace how the loader searches. The best practice is to control the search path explicitly. Use rpath $origin at build time to tell the loader to look for dependencies relative to your library. This way, libfoo.so and libbar.so can live in the same folder and work wherever you deploy them. So the next time you hit a mysterious crash loading a JNI library, remember it may not be the first, so that's missing, but one of its dependencies.